Okay, guys, y'all look up here. This is the wiring diagrams for the PLCs, and these are actually on up on Blackboard. This is using ISO standard symbols. So here's all our inputs. I don't know. Let me blow it up a little bit so y'all can. This is it's using industry standards or international standard symbols. It's not using the symbols that we would use. Now, what they're showing us here is this is your actual connector, XM2. This is that gray cable that you come in and plug into the top. And this is showing us which input it's actually connected to. So this guy is actually connected to input 0. And that would, of course, be 0.0, right? If you see this diamond shape, this means this is some type of sensor. If it's got this sign in right there, that means it's a capacitive sensor. This is a photoelectric sensor. This is a magnetic sensor. And these are Hall effect sensors. Now, why we know they're Hall effect sensors is because they got 3 wires. It's a 3-wire sensor. A reed switch sensor would only have 2 wires on it. Right? Does that make sense? So these are all magnetic sensors. And then we move on. These are the symbols that we use for direction control valves. These are the valves that's actually controlling the flow of the air, which causes the cylinder to extend or contract. These are not the right symbols. These are solenoids. They should have a cross. This is the valve itself. So these are the solenoids inside here that actually shift the valve in different directions to route to cause the cylinders to either extend or retract or move or stuff like that. That makes sense. And these are our outputs. So and these are what we call these are all 2 position sensors using solenoids to go in both directions. This only uses the solenoid to push it in one direction, and it's got a spring return on it, so that the spring actually brings it back. Everybody follow this? Okay. So Belton then ran into a situation where they got a section of output that has no resemblance on it. And what's those numbers? And when I look at the electrical diagram, what do I see? But what do we notice? They're not wired to anything. So technically they're not used. So yeah, now remember on Allen Bradley, the 500 doesn't, the 5000 uses tags. So if you program the RS Logic 5000, it's very similar to what you're running to the Siemens. It uses tags. What we noticed right off the bat when we did, before y'all started using symbols, in intro you didn't use symbols. What they did on the 500 is it didn't assign it a symbol. You had to come back and actually do what? Assign it yourself. What these new versions do, if you don't assign it a tag, it's automatically going to stick a tag out there. But it numbers them what? Tag 1, 2, 3, 4, 5, 6, and etc. And you go back and you put the right tag on it. You can either leave the defaults or you could do what? Or give it a name. And of course, it's a lot easier to give it a name because then you got this thing in your head. You know what it is. It's hard to remember tag 1, tag 2, tag 3. Why did I give the tag to, right? Without bringing it up. So they ran into a situation where they've got a bunch of outputs or 3 outputs that are in there, and they're resetting the outputs just in case, I guess, in case they somehow they got latched, right? You understand? somehow they got latched, it automatically resets, but according to this, they have no use in the actual program. That makes sense? So these are about the only sensors that we'll have. Is we have capacitive sensors. Let me bring up another diagram so y'all can. Which one has inductive sensors? The process section has inductive sensors. So all these diagrams, these electrical diagrams are up there. And this is something you would do before you built your circuit, right? You should come up with all these tags like y'all did, and you should go ahead and do the electrical. So this is what type of sensor is this? Can y'all see that? Let me blow it up. Yeah, this is capacitive, right? This is inductive. And this is photoelectric, right? Makes sense. And then the valves. So they got a 56 ohm resistor in this guy for some reason that we'd have to see. Of course, that's now this is the true symbol, ISO symbol for a relay coil. I'm sorry. Fine. This is the true symbol for a relay coil. Y'all know what relays, right? And then they give it a name, K5, or sometimes they'll give it different names. Here they're giving a K, and then we come up here and find out. And these are the actual contacts for those relays. Are you okay? This is a symbol of a DC. It's not the symbol of the entire motor. This is the symbol of the rotor, the armature of a DC motor. And so this is the little brushes that they have, and this is the symbol for the armature. Now all the motors that we have on the manufacturing line are what we call permanent magnet motors, which means they have a permanent magnet for the field outside that the rotor interacts with. So these are all permanent magnet motors. So you okay? So this is something you would do before you even started your diagram. You'd try to set up your tag table, try to figure out how many sensors you need. You'd go ahead and give them tags, right? You understand, right up front. That would make it easy. And then you'd also come up with these diagrams that shows how these inputs would actually be electrically wired. Now you're wiring it from this point of view from out here, right? So you didn't wire up all the sensors because they were already up there wired for us, and all you're doing is just making the connection to the PSC. So okay, so
hey, you have the line diagram.
What's that?
Yeah.
No, what we have is we have a book, and then I didn't. I think y'all had the book to start off with, right?
Yeah.
And they're back in the box back there. Make sure you get the one that's got English, because there's German and I think several that actually gives the wiring.